Yeah, there she is. And I have 25 minutes to save the world, so, so let's get busy. I think we all know that the Earth is in trouble. We are now entered into what's called 6X, the sixth major extinction on the planet. Like rivets of an airplane, as we lose species, the rivets are popping, and at some point we will come to a level of catastrophic failure. We don't know what is ahead, but I think we all sense that it's important that we do what we can to be able to save this planet. My wife and I spend a lot of time in the old growth forest. It's a place that we like to go on Sundays, so we feel going to the old growth forest is a very spiritual experience. I think the old growth forest has a lot of potential that is not yet recognized, as I think many habitats also do. In the Science news, on April 15th of this year, there was an article stating that all plants are part fungi. Indeed, there are mycorrhizal fungi in the roots of trees and plants. There are endophytic fungi, there are saprophytic fungi, as well as parasitic fungi. So it's interesting now that science, the more that we explore the interrelationships between organisms, we find that fungi are pervasive, that they are everywhere. In the Journal of Eukaryotic Microbiology, in December 15th, 27 authors co-authored a paper stating that there is a new super kingdom that should be erected, and I should use the word kingdom, and it's called Opaisthakanta. And this super kingdom recognizes that fungi and animals share a more common ancestry than with any other group. So some of the oldest remnants or the oldest records that we have of mushrooms can be found in amber. This is from the Miocene period, and here's a fully intact mushroom. It's 15 to 20 million years old. The oldest mushrooms found so far in amber are 90 to 100 million years old. Mushrooms had achieved their shape and form long before hominids had even evolved. So what do? We grow lots of saprophytic mushrooms, and this is the roots of the mushroom, otherwise known as mycelium. And the mycelium is extremely interesting to me. But what we do at our business is, and what happens in nature, is we take wood chips, we add mycelium, and ultimately soil is created. Mushrooms are the grand molecular disassemblers in nature. They are the soil magicians. And the end consequence of the decomposition of plant and animal forms result in soil. These are the interface organisms between life and death. I'm fascinated by how mushrooms rot. And this is an old Russula species. Prior to sporulation, it resists infection. So bacteria and other organisms are kept at bay. But after it sporulates, then these mushrooms give themselves up. And as they begin to decompose, spores germinate, and then very quickly the mycelium forms and goes into the ground. There are there's these vast networks of mycelium everywhere in the ground. In a single cubic inch of soil, there can be more than 8 miles of these cells. And I present to you the concept that the mycelium is sentient, it is intelligent, it knows that you're there. And because of the biodiversity of fungi in the ecosystem, when you break a stick or if you're chopping wood, there is this amazing competition of different fungal populations that reach up and try to grab that new nutrition. I spent years in front of the scanning electron microscope, and what's interesting also about fungi is that the mycelial networks are only one cell wall thick, but they are biofilters, and these microfiltration membranes catch the flow of nutrients, and they also hold water. And so in these microcavities, they fill with water, and then as rains wane, then they release water slowly. So myceliated substrates are spongy substrates, and all of us have felt the bounce factor when we walk in the old growth forest, because those membranes are infused all throughout the soils. I could not help but notice that the architecture of the mycelium resembled that of neurons. This is a micrograph by Hank Morgan. And I postulated in the Whole Earth Review that indeed mycelium is Earth's natural internet. Now I have to admit I went out on a limb on this one. But I was happy to see a group from Oxford at the last International Mycological Congress had 2 workshops specifically on the mathematics of the mycelial networks as a structural form. And when they optimized mycelial networks and the nodes of crossing and looked at internet mathematics and in its optimization, lo and behold, the mycelium had achieved a mathematical optimum, the very same of that of the computer internet. So going further out, I'm an amateur astronomer, and it's disconcerting to a lot of us to know that 97% of the matter in the universe is dark matter. We can't see it. You know, it all started with the Big Bang around 13.7 billion years ago. There was a spark in space. Maybe it was the touch of God. And then suddenly the universe was born. And through these great expanses in the universe, matter conforms to string theory, and these networks are created. These are individual oval galaxies. And looking at the aftermath of a supernova, the matter of supernova also conforms to string theory, and these mycelial-like networks also form. 4.5 billion years ago, the Earth coalesced out of stardust, and as it formed, life emerged, and the oldest organisms are approximately about 1.5 to 2 billion years old. The first organisms to come onto land were fungi. They came onto land 1.6 billion years ago. Plants arrived on land 600 million years ago. So fungi were on land first. But the Earth suffered a series of cataclysmic events. 250 million years ago, there was a great asteroid impact. And when it hit the Earth was shrouded in dust. We don't know for how long, maybe for decades. But the Earth became darkened, plants died, massive species extinctions occurred. And because there was no sunlight, and fungi required no sunlight, fungi inherited the Earth. And then as the skies cleared and the plant communities rebounded because of natural selection, the plants that paired with fungi then were favored, and they ascended. We marched forward again until 65 million years ago, you know the story, a second asteroid impacted. The Earth then again was shrouded in dust, and fungi re-inherited the Earth. As we entered into these Mycozoic periods, mutualism between plants and fungi were constantly rewarded. So the rule of life on this planet is symbiosis. The largest organism in the world is a mycelial mat in eastern Oregon, and we live approximately in this zone. And there's the Columbia River, and the largest organism in the world is in eastern Oregon. It's a mycelial mat, 2,400 acres in size, 2,200 years old. And in cultures, the mycelium can form spirals, and also the colonies of mycelium in nature form spirals. The mycelium can form this rhizomorphic strand, and this is a testimonial to its strength. These mycelial strands can hold 30,000 times their weight. They are tenacious. They grip the soils. They prevent erosion. They hold water. They establish vast microcommunities for all sorts of other organisms. In the mycelial network, we have 5 or 6 skin layers. The mycelium only has 1. How is it that the largest organism in the world can only be 1 cell wall thick? It's in constant biomolecular communication with its ecosystem. And I postulate to you that these fungi have evolved exquisitely complicated systems for reacting to catastrophia. This is the mycelium. Note what happens over here. This is a 1-hour time lapse by Nick Reed. And this is over about an hour. Those are nuclei. Now, the nuclei pair up as two nuclei per cell. There's hundreds, thousands at the tips of the mycelium. It infuses, it grows, it's around us at all times. It's alive. It knows that you are there. The mycelium then can form a primordium, a little baby mushroom. And the primordia are extremely strong. They're able to break through asphalt. This is a shaggy main mushroom punching through asphalt. We got involved in some experiments in breaking down diesel in Bellingham, Washington. There were 4 piles. 1 pile was treated with bacteria, 1 was a control pile, 1 was treated with chemical enzymes. The other pile was treated with our oyster mushroom mycelium. The mycelium is producing extracellular metabolites. It's absorbing the oil into the mat. The mat of mycelium becomes darkened and black, and then as it metabolizes the oil, it becomes white again. So the extracellular metabolites that are being secreted by the mycelium are custom manufactured in many cases in response to the circumstances around the mycelium. So it can exquisitely design its own suites of defenses, as well as digestive juices. Our pile produced thousands of pounds of oyster mushrooms. And the pile was decontaminated with polyaromatic hydrocarbons from 20,000 parts per billion to less than 200 in 8 weeks. The other piles remained dark, stinky, lifeless, and our pile rebounded with life. The mushroom sporulated, the spores attracted insects, the insects laid eggs. Some of these mushrooms became extremely large. This is what we call very happy mushrooms, because they're very large. The mushrooms turned out to be perfectly edible. They had no petroleum residues whatsoever. And then as the mushrooms sporulated and the insects came in, the eggs were laid, then the mushrooms began to rot. But the birds came in after the larvae, they brought in seeds. And so plants started to grow. So this is an example that fungi, as primary decomposers, can be keystone species that lead to habitat restoration and lead to a proliferation of life from habitats otherwise hostile and lifeless. So I'm going to describe some of the inventions that mushrooms have led me to, and mushrooms do lead me. I am the voice now. I'm the voice of thousands of generations that have gone before me. We stand upon the shoulders of our ancestors. This is a mold fungus called Metarhizium, which the EPA is recommending for treating against varroa mites that are destroying bees. It is a unique group of fungi that targets termites and carpenter ants and many of the other insect species that cause damage to crops as well as urban and suburban structures. I ordered some of these cultures because we had carpenter ants in our house, and there was a wedge of growth of mycelium. I thought, that's interesting. And I looked up in the literature, and everybody said, oh, avoid that, it means no spores. And there was this view, I think, a very macho view of more spores, more missiles, more death. And so the pesticide industry used spores to try to kill termites. But the termites and ants aren't stupid. They can smell the plague when they get close to it. So when they built bait stations, these bugs would come up and they'd smell the plague and they'd turn around and run away. I thought there must be a better way. And so I coaxed out the mycelium into this form where the sporulation is delayed, and lo and behold, I found something that was a breakthrough. This is our house, or it used to be our house. Our house finally was destroyed. There was 12 buckets catching water, the roof was flat. There was a storm one day, the house suddenly shifted and the roof was no longer flat, and I told my wife, don't worry, now the roof is no longer flat, we don't have to empty the buckets as more, and the water will flow off the roof. I'm always thinking the glass is half full. So I put the mycelium out in a Barbie doll dish at a location where carpenter ants were coming through. And lo and behold, the very fungus that would repel the insects and prior to sporulation attracted the very insects. Carpenter ants then took pieces of the mycelium back into the house, and then 2 weeks later, there was no evidence of any carpenter ants. Our house was protected then from reinvasion for over 4 or 5 years. And what's interesting is the mycelium is engaged by these insects. They're given to the queen. They're queen-friendly. The workers become little mushroom growers, and they spread the mycelium throughout the nest. And then they have this malaise, and they get sickened with the mycelium, and they become mummified. and then a mushroom pops out of them. So there goes the house. And again, I'm trying to put a happy face on this. And so the house was destroyed, but from the house, I received a patent against carpenter ants, termites, and fire ants. So this took hundreds of mycologists have been working on this. The pesticide industry has been working on this. No one knew that the pre-sporulating mycelium did the opposite of what the sporulating mycelium did. So this now allows insects to be targeted, to be selectively attracted to a locus. We then did extracts and did choice tests, and the termites would selectively go to where our extracts were, even when given 3 other choices. And then I'm very, very happy to say, the first time in public, after 5 years and many, many arguments and discussions, on Tuesday, I was rewarded with a new patent. This is a breakthrough patent. It's been called an Alexander Graham Bell patent. It's active against all social insects. Any insect with a queen, 100,000 to 200,000 species. This could totally revamp the pesticide industry. This could totally... I carry the weight of this intellectual property. I consider it to be an extremely important role. I have really powerful environmental principles that are attached to my patents. I have been engaged with the pesticide industry for the past 4 years, and I'm bound by confidentiality agreements, but I can ask you this question. Do you really think the pesticide industry that has billion-dollar profit wheels coming out of factories that have been paid for, that will tent your house for $5,000 and charge you $1,000 a year annual inspection fees, do you really think they want a green technology where I could get rid of termites and carpenter ants in your house for $1 forever? We also grow mycelium that is beneficial to insects, and this is Macrolepiota procera. This is a beneficial fungus that the ants cultivate, and the mycelium selects a bacterium that then also, then the bacterium is active as an antifungal antibiotic against Escovopsis, which is a mold fungus that attacks ant colonies. So ants and many insects cultivate mycelium as part of their host defense mechanism in preventing insects from invading their home, just like us. So one of my good friends is Dr. Andrew Weil, and these are polypore mushrooms of reishi, Ganoderma lucidum. And one of the polypore mushrooms we're extremely interested in is exclusive to the old-growth forest. This is Agaricon, Fomitopsis officinalis, now thought to be extinct in Europe. It only grows in Northern California, Oregon, Washington, British Columbia. Its habitat niche is the old-growth forest. And it has this ability, it infects these trees, but it gives them defenses against fast-acting parasitic fungi. And so only when the trees are really, really old, they actually climax a tree. The mycelium runs down from the top because it goes from the tops of trees when there's lightning strikes or storms, and then it infects the wood and goes down, and then it rots the butt of the tree. Actually, it is called brown cubicle butt rot. Something I hope none of you personally experience, you know. So this mushroom is very interesting. It's a perennial species, and I got involved in the U.S. BioShield program of the U.S. Defense Department. I submitted over 300 samples, and you can Google an interview with me on NPR in the BioShield Department. And lo and behold, one of my strains, actually several strains, isolated from these mushrooms, Fomitopsis officinalis, which also can have a Venus of Willendorf form. It was described by Dioscorides in 65 AD. It has a 2,000-year history of use in Europe, but now because it's extinct in Europe, that use has fallen aside. But we were involved in the BioShield program, and these are the results in a quotation by Dr. Earl Kern of the BioShield program. He was a smallpox expert in the United States. This is a in vitro test, but it's very significant. Anything that has a selectivity index of 2 or more is active. Anything over 10 or more is highly active. Fomitopsis officinalis hit the 20s and 29. 6 samples were selected by the CDC out of more than 200,000, and we believe more than 2 million for further study. 2 of the 6 samples were my cultures, specially prepared from these wood conchs that are exclusive to the old-growth forest. Smallpox knows no borders. Smallpox does not care if you're a Republican or Democrat. Those of you born after 1968, you have no immunization against smallpox. And so I strongly believe, and I'm a patriotic American because we have an old-growth forest, and I strongly believe this furthers the argument that we should save the old-growth forest as a matter of national defense. I have 3 more minutes to save the world. So I think about this a lot. I have 25 years left in my lifetime. The average males in my family live to the age of 76 or so. What can I do? What can we do? And I think a lot about the pairing of fungi with plants and using fungi in order to help habitats. So I dreamed up the life box. And the life box, these have every footprint we make on this planet has an effect. And in our ecological footprints, as we walk through the course of the day or through our lifetimes, what is the residual impacts that we have left? And so this is why the feet there are springing forward. So I invented the life box, which I think will revolutionize the packaging industry. 1% market share of cardboard in this country covers 25,000 acres of land, could cover 25,000 acres of land per week. 1% market share. We all get too many cardboard boxes, but here's my idea. You have a cardboard box delivering a DVD of the Bioneers. It could be that. And you take out your DVD of the Bioneers, and you add some soil to it, and you add some water to it, and there's 8 species of vegetables unified by a common single mycelial mat that's nurturing 8 different species of plants. And then you can have a cardboard box, could be shoes from Nike, it could be whatever. And then this is my daughter Ladina and our UPS driver Mike. Thank you, Mike. And so you add water to the life box, and then you grow corns, beans, and squash, the 3 sisters. And then my wife, who is a gardener, was really amused because she said, if you can do this, anybody can do this. So then I got some buckets, and I got an old bathtub, and I got a toilet, and I got the kitchen sink. And then 6 to 8 weeks later, this is the life box yield. And then from the life box, we harvested. Now, I originally developed this for refugee communities, and my idea here is to reinstill with children the importance of growing food and of ecosystems. And many of us have the same experience. I think most of us, I became a biologist the day in kindergarten when in my little Dixie cup, that sunflower spreaded its cotyledon leaves to the sun. I felt like God. So I thought, I want to know, that was a big epiphany in my life. So how can we reinstill that magic of nature? So I think the life box, if we get a 10% market share, that's 250,000 acres per week. We can combat global warming. The albedo effect, reflectivity of the planet will be decreased, will absorb and store more of the carbon within the plants. And so I started thinking about the energy crisis. I thought, and I had another epiphany. And this is a big one. So you can take straw, corn cobs, corn stalks, and this is brand new. We just made this slide yesterday, and I've invented myconol. Myconol comes from mycelium. Yeasts are incapable of converting cellulose into alcohol, but yeasts can convert carbohydrates into alcohol. So the great thing about the molecular disassemblers of these fungi is that they can get into cellulose and lignin, convert it into fungal sugars, and the fungal sugars then can be utilized by the yeast for the generation of ethanol. I believe that every community, every city, every village should have mushroom cultivation centers. They should be not viewed as just as mushroom cultivation centers. They should be reinvented as healing arts centers. They're integral for developing, growing soil, for growing food and medicines, for being able to combat pollution, to using microfiltration membranes to select out coliform bacteria. We've now been able to match over 100 different mushroom species against different toxins such as dioxin, PCB, PCPs, all sorts of other types of organophosphates. So I just want to leave with you now the hope that nature is our ally. We all need to be empowered by using nature's tools. The fungi in the biosphere are reaching out to us. It is our time. Let's get busy. Thank you.